Today we are going to deal with the example of reduce. When do you use the reduce method in streams of Java? So all this time we touch some the methods in streams and how to do stream processing. We dealt some examples where we were replacing enhanced for loops with streams, and we realized the importance of stream processing, and we also studied in the last example of a flat map. Now today we are going to study on how to use the reduce method. So let's start with an example here of how to start with a reduce example, uh, wherein we'll write a new class, and in that class we'll use the reduce method. So let me write my Java class, test 1, 2, 3, finish. And then in that class, we are going to deal on the reduce method. So the question first comes is that when and how, we use this reduce method. Generally, this is the definition of a reduce method. The reduce method is used to aggregate or combine elements into a single result. It's often used in operations like summing, multiplying, finding maximum, combining strings, and all. So, right now, just for the context for everybody, we are studying stream processing in Java, and we're going to deal about different methods we use in stream processing. So, let's name this as reduce example, reduce example. And what we will do is the example, what we're going to take, the example we take is very simple, just for understanding. We take would be to take a series of numbers, multiply and give the product, and give the product. So this is the example we're going to take in Java, where we take series of numbers, multiply and give the product. Now, as usual, I'm going to write a public static void main example. Uh, Public static void main string args. Now this is saying that I need to rename this class, which I will do. This example.java. So let's take this as an example. We have list of integers, and then that is the type integer numbers we have. And what we have to do is uh, find the product of all this, right? Note that we are trying to use the reduce method in Java here, and uh, there are more simpler ways to do this, but we need to understand the reduce method. That's why we have taken this very simple example. And after that, we are going to actually see how and where we would need reduce methods. But this particular program is focusing on how to use that method. So once we understand using the reduce method, then we can also go into situations where exactly the reduce method is needed. Now, the first and foremost thing is that we have numbers here, and we need to go into a stream operation first. So as we see in last examples, right, we can start calling the stream processing by, in a very simple ways to uh, put the stream operation. Yes, TREAM. Then this dot. Now, what after this? Of course, I called a stream. Here I need to declare a list, import list. Then we need arrays. And then numbers dot string. If we need arrays, quick fix. No, remove numbers and all assignments. No, it's not needed. Numbers dot string. Now, what next? So I need to, so we get all these numbers in a stream. So for each element in the stream operation, I need to say in a simple word is that take the first element, multiply it to the second element, take the product, and then that product multiply it to the third element, then take the product, then multiply it to the fourth element, then take the product and multiply it to fifth element, right? And how do you do that using reduce? So let's check the APIs for that. How the APIs help us to. So here we see the Java APIs for reduce operation, and it is telling that reduce takes input as an identity, the first argument T identity, and then it takes the second one as a binary operator, which is of type T accumulator. And what it does, it does a performs the reductions on the elements of the stream using the provided identity value. So we have to provide identity value and an associate accumulation function and returns the reduce value. This is equivalent to now what it says is T result is equal to, I mean, the equivalent operation, what it does is that as soon as you give identity is T result, and for every element Result is doing accumulator dot apply result and implement return result, but not constrained to execute sequentially. Identity must be a value, must be an identity for accumulator function. This means that for all t, accumulator dot apply identity is equal to t. The accumulator function must be an associative function. And what type of operation is this? This is a terminal operation. So generally people call this for sum, min, max, average, and string quantity, or all special cases of reduction. So it says, let's say integer sum, integers dot reduce. Now here the first element what I see is I am taking 0 as my identity, right? And then what I do is that I take the A as the first element here, right? And B is my next element in the series. And then so this is called as the binary operator accumulator. Uh, this is an associative accumulation function where the terminal, I mean, A and B are taken, and then you are adding A plus B. So this keeps, remember that this is not recursive. Recursive operation in Java is different than reduce. So an example they have given is the identity element is 0, take the first element, the second element, and then add it, and keep on doing this until it is totally, done all the operations on the series, all the series is complete. So this is about understanding the API, the reduce of the stream operations. And what is this? This is a terminal operation. So let's take the stream operation and then we would use something like this, reduce, right? In the reduce, I will give first my identity here. Since we are doing a product, we have to use 1 because we use 0, the thing will be 0. So we'll try to use 1. And then we have to use a binary operator. Since we are inside the stream, what I could say is that for every A comma B, what I do is A into B, right? This is what I think, would help us to do this. Note the simplicity of this, that you are using numbers dot stream and using a reduce operation. And when you do this, you get the output, correct? Uh, so we saw the Java API. We also saw, how we can use the reduce operations. We took an example here now. Next thing is that we will have to arrive at a result. So 1, let's put this inside the bracket. Then now we need to get results in the stream operation. So what does this say? Quick fix. Okay. Now it is giving me numbers dot reduce dot stream. And what if I rent this? Numbers dot stream dot reduce a, and if I say yes, my s system dot out dot PRINPLM. Would this work? We have to see. Let's see that. So now we got this. So let us try to execute this program and then see what is the result. Would we get some output for this? So before we go towards the output, let's summarize what all we did here. Uh, we started understanding how to use the reduce method in Java streams. The reason we are taking this example, very simple example, so that how we can use streams inside Java program, and inside the streams, how we can use the reduce example. So in the reduce example, we are going to we studied from the API how to use the reduce example, what are the first argument, what are the second argument, and all that stuff. We went to the Java API, and now we are trying to get the product. To get the product, first of all, we got a stream, and then we use this reduce method of the stream. So far, so good. Now, we are going to get the output of this, and the output should show us the result. So we got the result as 120, and this ends the the execution of a simple program of how to use reduce example. So in the next episode, we are going to take a practical example where the reduce is needed. For now, I'm going to keep it simple so that everybody understands what I'm telling. And in the next episode, we are going to see a practical example. If you like the video, hit the subscribe button or the like button. Thank you all.